So, good day everyone. My name is Junmar Carriaga. So, we are Group 1. So, today uh, our topic is about Lesson 6, Fuel. So, first, we have solid fuels under characteristics. So, given the solid fuel refers to a type of combustible material that remains in a solid state at room temperature and is used as a source of energy through combustion. So, here daw is a solid fuels nga maka-create siya og fire into a high temperature. So unlike sa liquid or gases, solid fuels do not flow because from the word solid palang daan. And they are typically characterized by their stable and compact form. No? So, sabotable naman siya. Solid fuels have played a significant historical role in various aspects of human civilization. So, especially from cooking and heating to industrial applications. So, sige. Wood. So, wood often used for cooking and heating. Wood is one of the most traditional solid fuels. So, it can be burned directly or processed into wood pellets for more efficient combustion. So, second example is coal. A major energy source historically and presently, coal is black or brownish black sedimentary rock primarily composed of carbon. It is widely used for electricity generation and industrial applications. So let's proceed about the characteristic of solid fuel. So number one is moisture. So this is the water contained and the wood. So when you burn wet wood, so the water must evaporate first, which wastes energy. So dry wood burns better because it has less moisture. So number two is volatile matter. So these are gases that are released from the wood when it heats up. So they include things like smoke, carbon dioxide, and other compounds that burn in the air. So the more volatile matter, the easier it is to start a fire. So number three is fixed carbon. So this is solid. The solid part of the wood that remains after the volatile gases has been released. So it's what actually burns to provide heat and energy. So higher fixed carbon means the wood produce more heat. So number four is ash. So this is the leftover material after the wood has completely burned. It's made of minerals and other non-combustible elements. Ash doesn't provide energy but can be used as fertilizer or disposed of. Now let's proceed sa calorific value. So this measures the energy release during combustion expressed in units such as megajoules per kilogram. So solid fuels vary widely in calorific value. For example, coal has a higher calorific value compared to peat, which has one of the lowest. Burning characteristics. Solid fuels exhibit different burning behaviors based on their composition and structure. For instance, wood burns with a visible flame and produce smoke, while manufactured fuels like pellets tend to burn more cleanly and efficiently due to their uniform size and composition. So here's burning characteristics. No, it describes how wood burns, including speed and efficiency. Storage and handling. Solid fuels are generally easier to store than liquids or gases. As they do not require special containers, they are stable and less hazardous to handle, making them suitable for various applications, including residential heating. Here's storage and handling. So it is the impact, the quality and ease of burning wood. So, environmental impact. The combustion of solid fuels can produce emissions such as CO2 and NOx, and also particulates. The extent of these emissions depends on the type of fuels and the combustion technology used. Modern advancement aims to improve combustion efficiency and reduce emissions through technologies like pellets stove and gasification. So environmental impact depends on the sustainability of the wood source and how it burned.
Lastly, solid fuels also differ in renewability. Biomass solid fuels such as wood and other agricultural residues are considered as a renewable resources, while fossil-derived fuel such as coal is considered a non-renewable resources as it takes a long period of time to form. The next topic is gaseous fuels and their characteristics. Now, gaseous fuels exist in a gaseous state at a room temperature and flow freely, unlike solid fuels, which has its own shape and doesn't occupy space. Now, natural gas is a mixture of paraffinic hydrocarbons, primarily methane. It is found in gas fields beneath the Earth's crust and in association with petroleum in oil fields. Now, there are two types of natural gas. It is dry natural gas and wet natural gas. The dry natural gas contains less than 15 grams per cubic meter there are two types of natural gas, the dry natural gas and the wet natural gas. The dry natural gas contains less than 15 grams per cubic meter of recoverable condensate, while the wet natural gas contains more than 50 grams per cubic meter of recoverable condensate. Now, these distinctions are based on the amount of condensable hydrocarbons present in the gas. This is the compositions and properties of natural gas. The table compares the composition and properties of dry and wet natural gas. Dry natural gas is predominantly methane, so Calvernia is 96.91%, with minimal amounts of heavier hydrocarbons, carbon dioxide, and nitrogen. In contrast, wet natural gas contains less methane, which is 77.22%, but significantly, but significantly higher but significantly higher concentrations of heavier hydrocarbons like ethane, propane, and butane, which contribute to its higher gross calorific value, which is 11,200 kilocalorie normal cubic meter. Now, compared to dry natural gas, which has only 9,000 kilocalorie normal cubic meter. Additionally, wet natural gas has higher specific gravity, which is 0.741, than natural gas, which only has 0.547, making it denser due to the presence of these heavier components. These are the several key uses of natural gas.
Hello, my name is Lorenzo Alvin Piasipal, and let's talk about compressed natural gas. Compressed natural gas is a fuel source that is made compressing natural gas to less than 1% of its standard atmospheric volume. CNG can be used in place of gasoline or diesel in any vehicle. Advantages and disadvantages sa mga sakuan sa compressed natural gas. Liquefied petroleum gas. It is mainly a mixture of propane and butane used mainly as cooking gas in domestic oven as well as industrial heating in the furnace. Liquefied petroleum gas is prepared from wet natural gas and refinery gas. It is highly volatile liquid which expands 247 times to its volume as vapor. So key features sa liquefied petroleum gas giingon naman niya diri nga highly volatile siya pressure that 247 times when converted into vapor, making it highly efficient for energy storage and transport. Nga, ang ikaduha niya key feature is clean fuel, producing minimal soot or smoke, which makes it suitable for indoor and industrial use. Di kaya siya abo. And number 3 is portable siya and efficient. It is easily transported in cylinder and tanks, make it more accessible in even in remote areas. Nga ang advantages niya kay is kuan siya eco-friendly, high energy efficiency and wide applications. Nga ang disadvantage niya kay kuan dependence on supply chains, cost fluctuations, and storage and safety risk. Next up we have is water gas. Water gas, it is the medium calorific value gas comprising mainly carbon monoxide and hydrogen gas. And next up we have carbureted water gas that has been enriched by hydrocarbon gases of high calorific value.
Liquid fuels and their characteristics. The liquid fuels can be classified as natural or pure oil and artificial or manufactured oil. So they have the advantage and disadvantage. So next, the petroleum and its characteristic. Petroleum is the basic natural fuel. It is a dark greenish brown and viscous mineral oil found deep in earth crust.
So let's proceed to manufactured liquid fuels and their characteristics. So first we have gasoline. Gasoline is produced either through the distillation of crude petroleum or by synthetic processes. It contains some unwanted components like unsaturated hydrocarbons and sulfur compounds. These are not good because they can cause problem in the engine. And gasoline has a boiling range of between 40 to 1200 degrees Celsius. An ideal gasoline should have these characteristics. So next is diesel fuel and its characteristics. So diesel fuel, also called gas oil, is derived from the crude oil through fractional distillation at temperature ranging from 250 degrees Celsius to 320 degrees Celsius. It primarily contains 85% carbon and 12% hydrogen with a high calorific value of around 11,000 kilocalorie per kilogram. So this means diesel is a very efficient energy source. And the main characteristics of diesel fuel is its ability to ignite easily under high compression. So its hydrocarbon molecules are designed to be straight chains with minimal aromatic or side chain structure, ensuring cleaner and more efficient combustion. So next is kerosene oil and its characteristics. So kerosene oil is obtained through fractional distillation at temperature between 180 degrees Celsius and 250 degrees Celsius. It has various applications such as fuel for lamps, jet engines, and tractors. And kerosene is significant in the development of jet fuel and has other domestic uses like providing a smokeless blue flame when burned in excess air, and it's always vaporized before combustion, which ensures cleaner usage. So lastly, we have heavy oil and its characteristics. So that's the end of our discussion about fuels and its characteristics.